The Neptunus filtration system is designed to purify lubrication, hydraulic, turbine, and other mineral oils used in rotary equipment by removing solid contaminants and moisture. This video is to let one understand the following points. 1. Need for filtration system. 2. Explanation of general arrangement drawing. 3. Manufacturing process of Neptunus filtration system. 4. Explanation of each line items in the BOQ. 5. Troubleshooting. Let's see the need for a filtration system in rotary equipment. A lubricant is a substance, usually organic, introduced to reduce friction between the surfaces in mutual contact, which ultimately reduces the heat generated when the surface moves. Over time, the friction between two metal surfaces creates wear and tear, leading to metal particles being deposited in oil, which left untreated can cause serious damage to the equipment. Neptunus filtration system uses cellulose filter inserts of 3 micron, 5 micron and 10 micron to capture such contaminants that are not filtered by inline filters in the engine. This saves the equipment from breaking down by maintaining optimum oil health. This drawing that you see represents the general arrangement of the model SE100 2R. SE denotes small economy, which is a system suitable for small scale applications. 100 denotes the size of filter inside the housing. R denotes the number of aluminum housing present. In this case, it's 2, hence 2R. If the model contains only one housing, the nomenclature will be SE100 1R. If it contains 3 housings, the nomenclature will be SE100 3R. Let's move into individual line items of the unit. Line item 1 and 17. Ball valve. We shall start the explanation from the inlet side of the unit. The first item on the inlet side is a ball valve. A ball valve is used to start or stop the flow of fluid in a circuit. This is where the inlet hose will be attached. The size of the ball valve is 1/2 inch and is made of stainless steel. To connect a 1/2 inch hose to the ball valve, a 1/2 inch male hydraulic union will be required. The suction line should always be less than or equal to 2 meters. Upon system startup, always ensure that the ball valves are in on position, both on the inlet and the outlet side. If it is not, the pump will run dry and can cause damage to the pump. Line item 2. Strainer. A strainer is a 50 micron filter used to protect the pump from bigger particles. Without a strainer, large contaminants will pass through the line, which will damage the internal gears of the pump. The strainer has a 3/8 inch opening on both the sides and is made of aluminum die cast. The strainer will have arrows engraved on its surface denoting oil flow. In and out of the strainer shall be established and mounted accordingly. Inlet will be attached to the ball valve and outlet to the pump. At the time of operation, if the pump fails to take suction, open the strainer body with an Allen key and fill the strainer with oil. You can completely fill the suction line with oil to prime the pump. Line item 3. Inline filter holding bracket. The holding bracket is clamped to the strainer, which provides support and prevents movement of the strainer body. The bracket is directly attached to the base frame. Line item 4 and 5, pump and motor. The pump and motor shall be sized according to the application. Pump's flow rate is determined by the RPM of the motor. SE 100 1R operates with a flow of 2.5 liters per minute. SE 100 2R in this case works with 5 to 6 LPM flow. The pump has an inbuilt pressure relief valve that will release once the pressure reaches 6 bar. The oil will be recirculated inside the pump when it releases. Pumps having lower flow rate, for example model DRT03, doesn't have an inbuilt relief valve. For such models, a line mounted relief valve will be installed in the pipeline. The motor shall be chosen based on the voltage and application. It can be either 415 volt or 480 volt.
Upon system startup, ensure that the rotation of the pump is same as that mentioned in the pump casing. If the rotation is reversed, the pump will not take suction. To rectify this, interchange any of the two motor terminals. Once proper rotation is established, the pump will take suction and the pressure gauge will show readings.
Line item 6 and 7, motor starter panel. 3-phase power supply to the motor is given via the starter panel, be it 415 volt or 480 volt, depending on the application. The starter is housed inside an enclosure and fixed to the vertical frame. Line item 8, manifold. The rectangular stainless steel block is referred to as the manifold. Its function is to house the pressure gauge, tan delta sensor, pressure transmitter, or any other sensors as demanded by the project. The stainless steel tubing passes through the manifold, allowing the oil to be in contact with the instruments mounted on it. Line item 9, pressure gauge. A pressure gauge indicates the pressure built inside the system. It has a range of 0 to 10 bar. For SE 100 2R, the pressure gauge will be lower mounted. For SE 100 1R, the pressure gauge will be center mounted. Pressure observed is dependent on the oil viscosity, flow rate of the pump, number of housings, and temperature of the oil. It is to be noted that pressure will be less than 2 bar when oil temperature is greater than 60 degrees Celsius and 4 to 5 bar when oil is at room temperature.
Upon system startup, ensure that the pressure gauge needle is not fluctuating. If the needle is vibrating rigorously, it is an indication of air entrapment. Tighten the suction line and strainer to avoid air intake.
Line item 10 to 16, AL100 housing. The AL housing houses the filter element inside. It is made of aluminium and has 2 openings beneath it. Oil passes through the inlet into the compartment and after filtration exits via the outlet. Stainless steel tubing will be attached to the housing, completing the circuit. The outlet of the housing will be extended and a stainless steel ball valve similar to the inlet side will be attached to it. The housing can be opened by turning the T-center bolt. Once opened, one can see the filter element, which can be of M, X or E type, and a bonded seal on the housing rim. The filter element can be distinguished based on their micron rating. M stands for 3 micron, E stands for 5 micron, and X stands for 10 micron. Line item 18, base frame. The position of the pump and the housing over a base frame is decided by the pump's orientation. The arrows engraved on the pump denotes whether the flow of oil is from left to right or right to left. In this case, the inlet is from the left side and outlet to the right. Hence, the pump is installed to the left of filter housing when looked from the pump face. Before manufacturing the unit, the foundation where all the items shall be mounted should be established. Drawing for the base frame will be dependent on the pump model, pump's orientation, and the number of housings. The material of construction for the base frame is mild steel and is powder coated with RAL 9005.